Okay, so hello everyone, welcome to my video. This is auto threshold remaining part for that project. Okay, let's start from where we have left off. So, giving the fraud, identifier, like in rule based conditions, like greater than 1000. So, it will learn the pattern effectively. So I will explain also all this. So what happens is that false positive and negatives will be negligible. We will see in testing part, and auto threshold generation will be there, and same stacking is used. Like base models prediction will be given to the third model, like two base models. The third model will train on their prediction and classify the fraud versus not fraud for call records. Similarly, for the fraud type as well, two models are there. Then third model will tell which type of fraud it is. It's a very simple, features we have made. Simply caller number is there, destination is there, minutes of calling, call start time and end time, and then there are fraud types, what type of different frauds that I have classified. There is threshold, what was the last threshold last time the alert fired, and this is the alert column. So it tells that last time which record was not fraud and which was fraud. Zero stands for not fraud, normal you can see, and one stands for fraud. Like different type of fraud names are there. So there are two y's this time, this column one y, this column one y. So these two columns that model will target to predict. So let's put a filter and I will surely tell you different type of fraud. So simply I have put some records and put the last thresholds and name it. Like you can see destination fraud. When we are talking about destination fraud, it is for particular destination like Angola, Bulgaria, Cuba, Albania. So what happened was last time caller numbers made some excessive callings. You can see here. What is the pattern? You can see here the calling patterns suggesting that every call is at least more than 1000 minutes. So simply the model should learn if this type of records will come, and then firstly it has to predict that it is a fraudulent and how much, and then what is the fraud type. For this particular, the model has to tell also that it is destination fraud. Similarly, you will go to high risk destination, and you can see here the calling pattern is saying that for high risk destination there are multiple calls to single destination like Latvia here. At least five calls are there, three calls for Guinea Bissau, and all are we can see that at least 200 minutes calling are there. So we have to train the model in such a way that it will catch those records, and then also give the name of high risk destination. Similarly, third type is overlap call fraud. You can see multiple calls are there, but you can see that similar number when calling, and 5 2 call start time, call end time 5:31, in between 5:28 call started. So for the same caller number, if same caller number call has not ended first call and next call started in between, then only we can tell na, we can say na that it's a overlap call fraud. So last time threshold was 90% and alert was one. These are fraud records mean one means fraud record. So model has to learn that when this happens, then it is overlap call fraud. No, firstly it is fraudulent record, and then the fraud type model will say that it is a overlap call fraud. So alert will fire. Okay, let's go to hack attempt. I tell I only four types I have given for very. That's why I have made very few columns, and few fraud types to show to audience, that the audience will understand easily. So PBX hack attempt, you can say here, see here, I mean caller numbers, Latvia, Cuba, Aruba. Okay, so what happening is you can see here short calls are there. I told you in last video PBX, when I made AI based PBX rules, that firstly the fraudsters use techniques to check whether the calls are passing or not. So they make short calls to check that PBX has been hacked, and then start abusing the services. So like that only, again the model will have to learn the pattern, and next time any destination pattern, similar pattern is there, then the alert model will fire, will identify it as a fraudulent record, and fraud type model will have to tell that it is PBX back hack attempt. And what I have done, I have also put to learn versus the normal versus fraud records. So these are normal records. These all are normal record. You have to give it, because model has to find a relationship between the fraud versus not fraud records. This requires domain expertise. When you are a fraud detection expert, then all this is needed. So, and you have to carefully train the model for all four fraud types, that it will not mix. I have fine tuned the model in such a way, and I will also show the results. But what happened, what is the benefits? I will tell you when we will go to the production part. So let's end this training records scenario over here. Okay, so let's the keep going the momentum, and we will discuss only these three version of these fraud models that I have made, and we will discuss the clustering reports in another video, because I have added AI agents in that. So let's go to the next. Okay, so this is the incoming record file that I have made. So it has mixed records, and model has to carefully generate the alerts for fraudulent records and name the fraud type. So let's discuss in detail. Okay, so as you can see in presentation window, I will tell which fraud is which one, and I have explained in training data also. So you can see here, I have named the frauds in FGHI column, or destination fraud, high risk destination, PBX hack attempt, and overlap call fraud. So I have marked as well, but I will mark here as well for very easy representation. So this is destination fraud calls, higher call duration greater than 1000 minutes, Cuba. Similarly to Somalia, you can see 3,977 minutes for Cuba, 1123 minutes. Then these one are high risk destination to Guinea-Bissau, 283 minutes call. I will mark them with another color, and this one with this one, or this one also 240 minutes to Guinea-Bissau, and this one also 20 minutes to Guinea-Bissau. So this will be high risk destination. The model has to predict correctly. Then PBX attempt calls, these one Latvia and Cuba, all you can see here, call short calls, 7 minutes, 10 minutes, 865. So these are all PBX hack attempt. This one. Similarly, the call to this one Benin. These are overlap calls. As you can see, one call has not ended and another call started. See here, 351 call started, 451 call ended, and next call in between started 415. So this number should be identified very effectively by the model. So okay, so now you can understand which one are false. This call to Namibia, this is false. This call to France and Bangladesh, these are false. This should not be flagged as fraudulent record. India and Australia also. These should not be flagged. So let's see what our model does. Let's fetch the model with these records. Okay, so before going to Python code and running, firing the alerts, I mean, from the model, we will just have a quick overview of ANN based fraud detection and why ANN differs from others. So simply, as we all know, what is ANN? Artificial neural network is a model inspired by human brain and it consists of layers of interconnected nodes, neurons. So here you can see biological neuron, which have these dendrites. So whenever we touch something hot or cold, these dendrites send information to brain, and brain is trained in such a way that it will take action whatever it does. So similarly, and we in deep learning we call these neurons as perceptron. So now you know that when we define AN model, it is called MLP, multi-layer perceptron. So in fraud detection, why it is beneficial? Because it learns complex patterns from data through multiple layers. That's why it is suitable for fraud detection tasks. Okay, let's go to next slide, and it will tell you more about it. Let me drag it below. Okay, so here we are, x1, x2, x3. This is input layer, means this is our you know neurons. So these features I have already written over here in context to our telecommunication fraud: call duration, minutes, overlap. So these are the features. It can be many more, but for representation purpose, only three I have mentioned. So these are passed to these neurons as input features. Okay, then there are corresponding weights. For x1, W1 weight is there. Similarly, W2 and W3. So what are these weights? These are parameters, that define the importance of each input feature. For example, if we want to give overlap feature more importance, then for W1 it is 1, W2 it is 1, again 1. Then W3 we will give the importance as 2. Then the importance become twice the importance of minutes and call duration. Okay, all right. Then why we all know that it is our predicted output. This is the result after processing the input. Means call records. Okay. So similarly, we have this one, green one, integration plus activation function. So yeah. So what it does, you can see here, it integrates the Wi into Xi, means every weight and corresponding neuron will be multiplied, and we will then do the summation. Summation will be sum of the value. Okay. So you can see here also one extra neuron is here, denoted by B. You can here see this is bias neuron. For this neuron, x naught is equal to 1. It is the value is usually 1. So 1 into B becomes B. So why this bias neuron has been taken? Because we will adjust the output of neurons through this. The activation function, treat it like an additional degree of freedom. So the bias, this is a bias neuron, will allows the activation function to shift the output to better fit the data. So you can I told you that take an additional degree of freedom, so that model will better fit. So when you have an extra neuron, so yeah, you can use it uh, to better right fit the model. So that's it from here. So that's why the equation was like this one: y is equal to wx plus b. And if we have multiple neurons, then it becomes y is equal to w1 x1 plus w2 x2 plus w3 x3 plus v. And and yeah, and when integration function combines the input, as I was telling you, combines the inputs of x and weights w and bias b, then what happens, it come up with, and when it sums up the values, so it comes up with the pre-activation value. And this pre-activation value is passed to activation function. Then it passes the value to the to introduce the non-linearity in the model. So this part is crucial. Understand the non-linearity. In just I will tell you in a very simple way. Uh, okay. Okay, so as I was telling about non-linearity, so without non-linearity, the model will simply build a linear relationship, and regardless of its depth. So take a simple example. means model will do this, like linear equation. What happens, we all know equation of a straight line is y is equal to m into x plus c. I have showed this in previous project also in detail, but simply y is our predicted value. What is m? M is slope, I mean rate of change in y due to x, and c is the interception value, where y is intercepted, and where x is equal to 0. So take the simple example. Some student is studying, x is our over studied and y is our exam score, and we are predicting y. Okay, so x is our input feature, over studied. See this, if the relationship is linear, what happens? Y is equal to, I'm taking in m as 2 and c as 5. This is just for representation purpose. So y is equal to 2x plus 5. So x is hours. The student is, how many hours per week the student is studying. So it will affect y. How much how y is affected. So over studied, we put like 10 hours per week. 10 into 2 20 plus 5 25. Then the exam score become 25. Similarly 20, when x is 20, 20 into 40, 40 plus 5 45. Exam score becomes 45. Similarly for 30 hours per week, 30 into 2 60, 60 plus 5 65. So you can see here, it's easy to understand equation of a straight line, and where x and y are directly proportional. Simply x is affecting y, and the relationship is very understandable, and this is linear relationship. So model will be, without non-linearity, model will build this relationship. But in fraud, we need to dig deeper, because there are a number of features which will affect the fraud pattern, and we don't know why they are affecting. So the model has to learn. I mean, the main thing is that model will be effective. The main aim is like that. So next slide. Let me go to next slide. Okay, so here are we in a nonlinear equation. So that's why I was telling that artificial neural network has to learn the nonlinearity because of this. Now understand non-linear equation. So what happened? Non-linear equation is it's parabolic curve. The relationship is quadratic. Means you can see like waves are like that, na, up and down. So the changes are unpredictable. So the equation is like that: y is equal to x square plus 2x plus 5. This is quadratic equation, and I have taken the same m and c as same 2 and 5 for representation purpose. Now see what happens. At that time, now we will put same use case. X is our over studied by a student, and y is our, we are predicting y, that is our exam score. Now when we put 1 hour, the student over studied 1 hour per week, per week, the exam score becomes how much? 1. The square of 1 is 1, plus 2 into 1 twice of 1 is 2, plus 5. So 5 plus 2 7 plus 1 8. And when 5 hours per week, so see now, 5 square, 5 into 5 25, plus 5 into 2 10, and plus 5. So 25 plus 5 30, 30 plus 10 40. So see, 5 hours per week. The exam score is 40. At least passing mark is 40, then the student is passed, just studying 5 hours per week. So do you understand now what these stats are saying on its own? Then similarly on 7 hours per week, so 7 into 7 49, plus 7 to the 14 plus 5, so it becomes 68. So if the exam score becomes 68, just studying 7 hours per week. So as I was stating, small changes in x can lead to unpredictable changes in y. That's why AN goes for non-linearity, because we don't know in fraud detection or in any other complex relationship which factors are affecting. So similarly, if I okay, so as I was stating, yeah, so you can see here small changes can lead to unpredictable changes, and y is not proportional to x. Similarly, when here only you can see that some in linear equation, when somebody was studying 10 hours per week, the score was 25 only, 20 overs 45, 30 overs 65. But here only these values have given so much high score. So you must be thinking, what is the difference, how they are performing well. So that's why the non-linearity, and we need means we need non-linear activation functions like we use in artificial neural network, like sigmoid function is there, and then tanh function is there, ReLU function is there. They all enable the network to capture complex pattern in data, which is required for our fraud detection. That is very much needed. So that's why I believe that was a very simple yeah, way to telling about this. And now we will go to the production. Okay, so here we are in the coding screen, and you can see here the same CSV file I showed you is given to load here. We made a data frame data, and then pre-processing steps are there, and do all the encodings and whatever imputation and cleaning of data, and inputting the data is done. Then here you can see the important part is that when we are adding features, mean these are the fraud identifiers I was telling about. So initially we are setting zero values, and then we have made these fraud functions to generate those identifier, like for overlap call. So this will calculate how the identifier is given, like this only. For overlap call for identifier, if call identified as overlap, identifier will be given. Similarly for PBS hack attempt, you can see here if the conditions are given, so identifier will be given. Similarly for destination fraud, the calculation has been done, uh, whatever is needed for the destination fraud. And then for the high risk destination identifier as well, we have segregated as per our fraud rules. We because for different types there are different conditions. You can see distinct color greater than equal to 3 for assign high risk destination identifier. So you have to make the conditions, you have to make the rules yourself as per your business requirement. Here we are assigning the values to the function, thresholds to the function. You can see here previous Adams threshold is 10 minutes, like 1000 minutes for assigned destination. I mean, destination fraud. Similarly, for a high risk destination, we are assigning time window also for a threshold of 200 minutes also. So what happens is this is hybrid. As I told you, this is hybrid approach. So traditional based system, you can give all these thresholds, but the thing over here is that you are getting probabilities by the model, high, low, and then you have fraud type. The fraud type will be which fraud type detected by the model. Then you can automate the high volume of data, and even no manual updates. Whenever you have new fraud pattern, you have to update this. This is the training code. So what happens is I have put some thresholds. The system, it will identify the this function will generate identifier, and model will learn on it. So you can see here alert model. Here you can see I have synthetic data also increase the data because data is very less. So for better accuracy, I have increased the data, and here you can see if I will tell you. So alert column, you can see here our x and y. See x, we have dropped the alert column. Big Y, why? Because alert column is our y. So the 0 and 1 alert column was I told you model has to learn that to predict correctly 0 and 1, 0 for not fraud, one for fraud. And similarly, you can see here when I'm initializing the model, we are using multi-layer perceptron. Two AI models I have taken, ANN models. You know why? Because I will take the predictions from two models, and then for the final model, that is logistic regression, will learn the prediction from this model and then classify the transaction record as fraud or not fraud. So you should understand that the similar model have similar functionality. So the model, whichever model, ML models you can use also, but they should support each other. Okay. Similarly, I will tell you, these are two AI models, and third model is logistic regression, which is doing classification task. Similarly, for fraud type, again, fraud identifiers are there, and I have taken the models as you can see here. Random forest, that is absolutely bagging model, decision tree model, first class model in machine learning for patterns. And MLP, another is MLP class of AN model. So for fraud type, like you can see here, the mapping is here: overlap, destination, high risk, PBS. Which one is that? For random forest plus MMLP, ANN model, then third model is logistic regression model. So the prediction from these model will go to this, and then this will initially make the final decision which fraud type it is. So the model should support each other. You should have a ideology of how the model works, because in maths 1 plus 1 is 2, but if the model are predicting differently, then -1 plus 1 is 0. So yeah, this should be in mind. So see, this model has been will be saved as this has already been saved as stacking model updated 122, and that the previous one was stacking model at 1 to 1. So this is all functionality from here. Now we will go to the prediction code. Okay, so here we are in coding string, and we will test the scenario with our model 1.0, final model 1.0, that is alert plus fraud type model. So here again we have all the in prediction code also we have to generate the fraud identifier, so that model will the trend model will make prediction accordingly. So let's see the data itself. Yeah, so this data will be given, as I told you. I have simplified for easy understanding and presentation. These are yellow records have to be fired by our auto threshold model, and it has to give the fraud type like this. These are destination fraud. These are actually these are correct fraud types. And but I will show you where is the record file is here only, like this: call cdr3 underscore call underscore cdr3 underscore all. So you can see here. Oh, sorry, not this one. Okay, this one, call cdr new 3, this one. Okay, yeah. So it just have the records only and the corresponding features, like this caller number. So this will go, and the prediction will be made upon it. So as I was telling you that I have copied the data, and I have the representation purpose I was seeing. So these records like this, these two records are correct. They should be identified like Guinea-Bissau calls. They will be identified. So yeah, I will just close it now, and I will go to coding screen again, and I will show you. I'm not making this up. Okay, so here you can see call CDR. I will put it now new 3, because there are different data files. So we want to make partition of this file that I just show you, call CDR new 3 on G drive. Here the same I opened. So get ready for the predictions. Okay. So what happening is this data will be loaded, and I mean that yeah, the data will be loaded, and the models will be loaded also. You can, if I go below, you can see somewhere in between the saved models has been assigned. Okay, so yeah, okay, here you can see load models. Alert model, same that one two one and one double two was for time model. So firstly, alert model will predict which is a fraudulent record, and then on only those fraudulent records, another model, stacked model, will tell what the fraud type is, and we will see the results. Now I will just hit the code button, and code has started executing. You can just wait. You can see here time scroller is running, and soon the results will be there. See, wow, what a beauty. So just go, and we will just go below, and these are the generated alerts. So I have not placed the email coding, I mean email alert code here, so we will just have a understanding first. This is testing part, so let me show you this one. Yeah, so firstly, destination fraud should be like this one: calls to Cuba, Somalia. Okay, so yeah, you can see here fraud type destination fraud. Then fraud type destination fraud. Again, another for this one: destination Somalia, destination Cuba. So all both calls 1123 minutes, 3977 minutes has been correctly identified as fraud time destination fraud here. Destination fraud 1123 3977 for Cuba, for Somalia, correctly identified. Then these all are short calls. You can see here PBX hack attempt for these this index number 3 here: Latvia, Cuba. Okay, so here ending with 501 and 502 here, ending with number 501 PBX hack attempt, ending with 502 PBX hack attempt. So the calls Namibia and all should not be there because they are not fraud records. So you can see here next is fraud type high risk destination 240 minutes, and then overlap call, and then fraud type high risk destination. So three fraud type high risk destination are there. Okay, so we can see here fraud type high risk destination, this one you can see. If I bold this one, if I bold this, okay, and then this one. Oh, sorry. Yeah, these three: Guinea-Bissau, number ending with 8562, 78, and 60. So number ending with 9658, number ending with 78, number ending with 60. Guinea-Bissau, Guinea-Bissau. Okay, so they are also correctly identified, and then overlap call number ending with 24376, same number, fraud type overlap call fraud. Is it here? I told you that it should be identified, so correctly identified. So model has correctly identified, I mean, 100 out of 100. So I told this is why, because it identifies and classifies multiple frauds and providing a clear picture. You can see these five records are left, and if I show you the coding part, you can see the probabilities also coming here also. You see 89 for destination Cuba. I mean for destination first destination fraud 89%. Second call more than 3000 minutes destination fraud. This one, which is the what is the index number 2 for 92%. So like this, and even I have put the debugging command like this, for all records. I will show you just here in the output window also. Let me go. Yeah, okay. Just wait. Don't angry on me. Don't angry on me. I have put here. Okay, here it is. All records with their alert status and probabilities. See, Alert means I told you na the model is has learned this column with the records to so not fraud. Okay, this one number ending with 3214, not fraud. Number ending with 379, number ending with 257 and 703. These all five calls, one, two, three, four, five, are not fraud. And you can see the probabilities. Model has, given probability of 5%, 5%. Then this one 5% only. Then this one 7% only. So why? Because model identifies that these were not in the training record. So these all destination and whatever feature engineering was there, call durations, call timings. So the model have learned that these are not frauds. So that's why calls to Namibia, calls to France, Bangladesh, India, Australia, they were not present as a fraudulent record. So model has clearly say that this is not fraud, and on those fraud records where value is one, the another model that was random forest and AI model, and third model was logistic. They have predicted the fraud type like this. Correct fraud type. You can see I have placed the records up and down in such a way that I can bluff with the model, but model has caught it well, caught it exceptionally well, means 100 out of 100. So let's hit the email alert code as well, and this is the same code, just email function is there. So here you can see the alert will fire for the same. So I will just check that whether the file is the same or not. I will just change it to CDR, call CDR new 3. Now it's okay. Now we'll fire the, I will run this code and fire the alerts. Okay. Okay, so yeah, code has started running. You can see, wow, it has started processing the, record as well. And soon you can see here, wow, alert sent successfully. Simultaneously, we will go to the screen. See here, wow, what a beauty. Alerts are coming. And alerts should be also, precisely no false positive or no false negatives. We sorry. Oh wow, what a beauty. B1 AI based fraud alert. See, the code is completed, and here you can see the, yeah, generated alerts. The printing screen is stating that wow, what a beauty, hack attempt, these, and you can see in the email window the alerts are generated like diamonds, bang on, right on target. Destination fraud. If I click this, you can see, and I will tell you now what is the difference. You can see P1 AI based fraud alert for this number, caller number, fraud type detected. So already on duty analyst knows that that this is destination fraud. That already AI has predicted. And the dear user, this is an AI based fraud alert for caller number this one with high probability of fraud. Here are the details. Cuba, calling 1123 minutes. Fraud type, destination fraud. AI based system disposition for this alert is fraud. Outgoing service for this caller are temporarily barred. So you can see now what is the difference between the traditional rule or condition based alerts, and this is a hybrid approach. So if we know that the probability is high, we have taken the system action. Outgoing service or caller are temporarily barred. System before generating the alert, and I will treat me as analyst, and I'm checking it right now. Before that, if it was not AI, then I have to go and see that whether it has history of calling or not, whether it is new customer or old customer, and many things that the standard operating procedures and workflows. But now, because the model has already found pattern as fraudulent and taking the action before the human analyst. I mean analyst action, before the analyst action, system action has been taken. So wow, what a beauty. So like PBX hack attempt. Okay, so see, this is an AI based fraud alert for caller number. This one high probability of fraud. So Latvia caller number are grouped by single same caller number, 5 7 10 minutes. Fraud type is hack attempt. Again, the distribution is fraud. Outgoing services are temporarily barred. And we see for overlap call fraud. See, perfectly perfectly generated for the same caller number. 351, 451 is the calling time, and in between 415 the call initiated. So here the high probability of fraud type detected, overlap call fraud. Here also same, and outgoing service system action has been taken. And last we will see for high risk destination. See, what a beauty. Guinea-Bissau, 283, 240, 280. So you can see now P1 AI based alert for Guinea-Bissau. Instead of caller number, there is Guinea-Bissau. So model has known that that collaborated calls to single destination are also fraudulent. So that's why high risk destination. Why? Because for single destination, multiple colors, different colors. That way I put the condition. I told you distinct colors. See, number ending with 9658, 7478, 51260. These are distinct numbers. That's why if distinct numbers are calling with so much of duration to single destination, this is something dicey to catch up. So this has been because these were same pattern in fraud records. So again, high risk restoration fraud type, and the call number are temporarily barred. So see, this is the beauty I was telling you about. That this was, I told you, this was a very advanced artificial plus ML, AI plus ML intelligence based system setup, high level artificial intelligence by machine learning setup. So I have shown you everything for this. Now what will happen? Now what will happen? I will tell you that I was what I was telling you, that this one, this was hybrid fraud detection model that I have just showed you, which has all system actions, and all the approaches for automation and alerting model plus fraud time model.